Hi, I'm Greg Pollock, and you're watching the course Advanced Components. In this lesson, we'll be taking a look at template compilation and render functions, starting with learning about the virtual DOM. We'll be improving your debugging skills because we'll be diving into the covers of how templates are rendered. We'll write our own render functions and learn how to create powerful abstractions that can help us scale our Vue applications. Component template rendering has two steps, and this happens after reactivity is all set up. Step one is compilation, where we compile our template into something called a render function, which we'll learn about in a minute. Then step two is running the render function. This will create a vNode, or virtual DOM node, which we'll also explain. And this gets loaded into what we see inside of our browser. When we use the Vue CLI to create a new Vue application, we're asked a few questions, including which build should we use, runtime and compiler, or runtime only? What this is really asking is, for what gets sent into the browser, do you want to include the code that's able to compile templates? If we do, then we include the runtime and compiler, which is 32K, otherwise just the runtime only, which is 22K. So the compiler is about 10 kilobytes, and it's not included when we select runtime only. What that means is if I pick runtime only, I've got to put all my templates in .vue files, which will get compiled into render functions at build time. It's worth noting that Vue CLI 3.0 defaults to runtime only, so it won't even ask you if you want the runtime and compiler by default. Let's jump back into our two-step process. Step one of compiling the template into render function can happen on the server or the client side, whereas step two of running the render function, which creates a virtual DOM node which updates our browser, only happens on the client side. You might be wondering, what does this render function look like? What is this vNode? And what's this virtual DOM thing? Well, let's jump into those questions now. First, we all need to know what the DOM, or Document Object Model, means. And if you already know what this means, just look at the pretty animation. It'll be done in a second. This is our browser's interface to change what's displayed on the screen. So here you can see my HTML. This HTML is mapped to DOM nodes, which look something like this. And then our browser might display something like this. So this HTML maps to a series of DOM nodes that we can manipulate. So let's do that right now. If I run some JavaScript, document get elements by tag name h1, and then I update that text content, it's going to update this node, which will update our browser. DOM trees can get really big and have thousands of nodes. This is why we use JavaScript frameworks like Vue to do the heavy lifting. However, searching and updating the DOM can still be really slow. This is why we have the virtual DOM, and this is not unique to Vue. Lots of JavaScript frameworks have a virtual DOM. This is simply a way of representing the actual DOM with JavaScript objects. So if I have a div, which looks like this, we can represent this using a JavaScript object in a vNode using something like this. vNode just stands for virtual node. Vue knows how to take this virtual node and create a real DOM node. When vNodes start to change, this is when the virtual DOM starts to really scale. See, if our vNode changed to goodbye instead of hello, Vue knows how to compare the old and the new vNode and make updates in the most efficient way inside of our DOM. Another way to understand the virtual DOM is as blueprints. Blueprints to, let's say, an actual building, or the actual DOM. There are two ways I can make changes to the actual DOM in this case. Let's say I've changed some data on the 29th floor. I changed the layout of the furniture and added a new kitchen island. I've got two ways to update it. Well, first, I can just demolish everything on the 29th floor and start over, or I can create new blueprints, compare the old and the new blueprints, and make updates, just doing the minimal amount of work. This is obviously more efficient, and it's what the virtual DOM allows us to do. Let's step through the component rendering process with an example. Remember, the template creates the render function, which creates a vNode, which updates in our DOM. Here you can see we have a simple Vue application with our root instance and a simple template. When this gets run, it creates a render function. If we loaded this in a browser and took a look in the console into the value of app options render, we would see something that looks like this. It's running create element with div and hello. This function returns this vnode you see here. It's just a plain JavaScript object. Vue takes this and creates a real DOM object, which we see in our browser. This works fine, but how might we create our own render function and skip template compilation? Inside our code, we can write render create element and just return create element, just like you see here. This returns the same virtual DOM node, which gets rendered out into our web page. Often when people write render functions, instead of writing out create element, they'll simply use the H method as an alias. H, in case you're wondering, stands for hyperscript, as in hypertext markup language, HTML. The next question I want us to get curious about is, when does this vnode get inserted into the DOM? There are several steps involved when we initialize the component and insert our vnode. First, we initialize events and the lifecycle. We initialize injections and reactivity, that's our state. If the template exists, we'll compile it into a render function. Then we'll start mounting, that's where we take the vnode and insert it into the DOM. And once mounted, we'll see hello in our browser. Now, in between each of these different items, we have our component lifecycle hooks, which you're probably already familiar with. We have before create, we have created, before mount, and mounted. I don't know about you, but when I got to this point, I started to wonder, what happens inside of mount in this whole lifecycle with regards to component rendering? Remember back in lesson 1, we watched this code for reactive properties, and if they got accessed, then we remembered this bit of code for later to run it again if those properties got set. Similarly, in the Vue codebase in lifecycle.js, inside the mount component function, we have our call hook before mount. Then we have a function, which is basically going to be our target, if you remember the first 2 lessons. Inside there, we can see that it calls our component render function, and it's that anonymous method that we send into our watcher. Let's take a look inside a simple Vue application to see what happens when we begin to mount. You can see here we have one reactive property, which is name, and we're simply rendering out a div with the name. First, there's the before mount lifecycle hook. Then we set our target. The render function gets called, and inside the render function, it accesses a reactive property. The getter gets called for .name, and it calls dep.depend to remember the target. The render function then returns a vnode, and we send that in to the update method. This update method interfaces with the actual DOM, and we see Greg on our screen. Now we're mounted. But what happens when reactive data changes? For example, if we go in our console and we change the value of name to Adam. This will call our reactive setter, and it will call dep notify, which again runs our target. The render function gets called. This returns a new vnode. We then call before update, and Vue compares the old vnode to the new vnode, finds the differences, and patches the pieces of the DOM that have changed. Once this is done, we get updated. This updates our browser, and then it calls the updated lifecycle method. Jumping back into our render diagram, you can see where we collect dependencies and we notify of changes, but also there's our watcher. And remember the code we just saw, our watcher was created with this piece of code, and our update component anonymous method is what calls our render function. It's this render function which returns a virtual node, and here in the diagram it says virtual DOM tree, because that one node can have many child nodes. I know when I first put all these pieces together, it was really exciting. My mind was blown. I hope yours is too, maybe just a little. Over the last 3 lessons, we decrypted together all the different symbols you see in this image. I hope it makes a lot more sense to you, and with any luck, we've made Evanraw proud. Before we're done with this lesson, I want to show you 2 more examples to get comfortable with this create element syntax. What do you think this render function might create? Well, as you can see here, it's creating an unordered list with several list items. Notice the second parameter is just an array of child nodes. How about this one down here? What do you think this render function returns? With a second argument, which is now a data object. Here's the HTML it returns. The create element function has a lot of different options, and you can see this in the link I have in the resources below this video. Now that you're familiar with render functions, we can talk about putting JSX in here, which you might be familiar with if you're coming from React. So with the help of a Babel plugin, we can write render functions that look like this, where we simply put the HTML right there, inside the return. Using the H is required in this case. To get this working, you'll want to use the Babel preset view library, which you can see here. All this does is transpile JSX into H functions. These are equivalent. It's useful to know render functions when you need to extend the functionality of Vue. For example, what if we wanted the header size to be supplied dynamically from the database? Maybe we have a directive called custom heading and we send in the header size. In our case, we'll just send it in from the root instance. This wouldn't be possible without a render function. So here you can see our render function. And take a moment to think about, what do you think goes inside of the H? Inside the H, we can dynamically output an HTML tag and just write H plus this level, and then pass everything inside of the component tag through our default slot, which might contain children elements. This would then print out H1, hey there. When the first parameter we send in to the H function is an object, Vue assumes that these are component options, and we want to create a component. So here you see some simple code where we have a JavaScript object, and then inside of our root instance, we have a render function, and we simply pass these options into H. This gets rendered as a component, and we see hello there printed to the screen. This can be really useful when we want to dynamically render a component, and we'll see some of those patterns in the next lesson. But first, let's review. In this lesson, we learned about template compilation and render functions. We learned all about the virtual DOM and how we take a template, it creates a render function, which creates a vnode, which gets rendered in the browser. We improved our debugging skills. We learned how to write our own render functions, as well as a hint towards powerful abstractions that we can use to scale our Vue applications when we know how to use render functions. Thanks for watching. Let's jump back to our 2-step process. The first step of compilation can let's jump back into our 2-step, just doing the minimal amount of work. Now let's take a look inside when we mount. The second parameter here, one of the reasons it's useful to know render functions. One of the reasons it's useful to know how to use